Now, the reflexive property is one that I think of like if you're looking at your mirror. Now, just so you know, all these properties is what algebra is built on. Okay? So, everything that we do in algebra class is based on these. Okay? So, knowing these or how they work is what you need to know. You don't need to memorize like the definition per se, but you need to know how they work with one another. Okay, so reflexive property is very easy. So if I say A is equal to itself, so it's A. So it's like looking in the mirror. So if I can see I'm standing right here, there's a mirror in front of me, I see myself, so A equals A, and A equals A. Okay? So then a number example for that is saying 2 equals 2. Okay? It's kind of trivial, but you have to start with that concept, knowing that one number is going to equal itself so that you can move on. Okay? Symmetric property is if I have two things that equal each other. So like A equal to B. Then I can also say that B is equal to A. So reversing the order of how you write your equality doesn't change whether they're equal to each other or not. Okay? So if I say that I'm equal to this trash can, then if I move and it moves, I'm still equal to this trash can. It doesn't matter where I am. Okay? Transitive property. Oh, I guess first I want a number example. So like if I have 2 equal to 1 plus 1, then I can say 1 plus 1 equals 2. Those two things mean the same thing, even though I reversed the arrow, the order. Okay? Transitive property is if A equals B and B equals C, then because both statements share B, it's like saying A equals C. Okay? So a real world example is if I hand Cody a piece of paper, then Cody hands that piece of paper to Tyler. That's the same thing as me handing the paper to Tyler. Okay? Just because Cody was the middleman still means that the paper got to Tyler, whether I handed it directly to him or Cody did. Okay? It's a figure of speech example. So if I say 5 equals 3 plus 2 and 3 plus 2 equals 1 plus 4, then I can say 5 equals 1 plus 4. And I know those are just like simple, easy, dinky like examples, but that makes you realize, like, makes it come into play. Okay? And then substitution tells you if you have A equal to B, then any statement after that, you can say, you can plug in A for B, or you could plug in B for A. So you can sub in both. Substitute. So, let's say I have 4, I want to say A equals 4. Okay? So then if I have this other statement over here saying 4A, then because A equals 4, I can take 4 and plug it in for my A. So 4 times 4 gives me 16. So these two statements are equal to one another because of the substitution property. Okay? Okay? Now, you have commutative property and the associative property. Okay? Now, whether there's addition or addition or multiplication, it doesn't matter. It's just the signs in the problems or and the properties change. Now the reason why you don't have subtraction and division is because those don't work the same way as addition and multiplication do. Okay? So addition and subtraction, addition and multiplication, you can switch their order around and do a lot of things that you can't do with subtraction. Okay? So commutative property just means basically that if I'm adding two things, then if I switch them in order, then it means the same thing. So you can have 2 plus 3, that's the same thing as saying 3 plus 2. Right? Pretty easy. Okay. Associative property is if I'm adding several things to one another. A plus B plus C. And then A plus B plus C. So here, I can group things to have them do them first, but then switch that grouping, and it still gets me the same thing because I'm adding. So let's say I say B plus C I want to do first, and see what happens. That's also equal to if I do A plus B first. Okay? So let's say 2 plus 3 plus 4 is my statement. Okay, let's say I want to add 3 plus 4 first and add 2 plus 3 first in two different things to see what happens. So 3 plus 4 is 7. 7 plus 2 gives me 9. Okay? Write that down. Then 2 plus 3 is 5. Plus 4 gives me 9. So notice how just because I put parentheses around something and did it for another something, I still got the same thing because it's all addition. Okay? Okay. So multiplication is the same as addition. So then what would be my general label for commutative property for multiplication? How would I write that? Using the A's and the B's. No. Okay, so A times B equals B times A. So a number example of that is what?
56.
What? 56 what? Times? 56 times 56?
56 times 2.
So 56 times 65 is equal to 65. Oops. Times 56. Right? Those two things mean the same thing. Okay? What about the associative property for that? Look at your addition, and what would be the same thing? What would be my general? Where do I put the parentheses for the left side of my equality statement? B and C. And then for the right side? A and B. Okay? So same thing. If I multiply B and C first, or I multiply A and B first, it's still going to get me the same answer. So let's pick some easier numbers than the last one. 2.
8.
5. I'm going with 5. Then 2 times 8, then 5. Okay? So on the left side, it says 8 times 5 is 40, times 2 is 80. Then on the right side, it says 2 times 8 is 16, times 5 is 80. Same thing. Okay? Right. Then the last one. Now, distributive property is very special in comparison to the rest of the properties because it involves multiple operations. Okay? Not just one like the rest of these were. Okay? So, if I have a letter times, it's like our problem that we had for number 2. where it said 2 times x plus 3. So you're saying A times the quantity of B and C. Yes, sir.
So you just like, instead of doing the problem normally, go A times B and then A times C?
Yep. Now, if you were given just all numbers, like, let's talk about this. So 2 times 3 plus 4. So then, if you did that, then 3 plus 4 with 7 times 2 is 14. So you would probably more likely do it the regular way for order of operations. But if, let's say, you have something like that where the terms inside your parentheses don't really go together because x and 4 are not like terms, so therefore now you can use the distributive property and multiply the 2 to both, okay, to get 2x plus 8. Okay. Now, the one thing that we'll talk about and we'll practice a lot, hopefully, when we get to the distributive property, is that when you're multiplying, most kids see or just forget about this number on the backside. So they see that and think, okay, it's just multiplication of 3. 2 times 3 is 6. And they forget about the back one because there's parentheses around everything. They just see this. They may just think that it's one parentheses in front, so it's just talking about that number. So there's a parenthesis on the other side of 3, which you're used to seeing for multiplication. Okay, but when you add more things to it, that 2 goes to everything that's inside. So every term that happens. So that's why we need to work on multiplying to this back number. That's something we have to work on. Okay. Now, distributive property works when there's addition inside and when there's subtraction inside as well. Okay.